Folks, we've reached the last day of our microeconomics final exam review. Day 10, let's dig into what you actually need to know about game theory. Dominant strategy, Nash equilibrium, and prisoner's dilemma. All right, let's first understand dominant strategy here. We're gonna zone in on this game theory right here. John and Sarah, they're essentially prisoners and they're getting dealt jail time. We're specifically gonna zone in on John here, and I've highlighted in green John's dominant strategy. The reason it's his dominant strategy is because whatever Sarah does, John confessing is his better option. If Sarah confesses and John confesses, John gets 5 years, whereas if John stays quiet, he gets 10 years. So it makes sense for John to confess if Sarah confesses too. Likewise, if Sarah stays quiet but John confesses, he goes free, whereas if he stays quiet, he gets 1 year in prison. So once again, it makes more sense for John to confess, and therefore it's his dominant strategy. He's gonna do it no matter what. My biggest tip when trying to find the dominant strategy, because it's one of the first things you should do in game theory, is just completely ignore the other party and focus on the rows or columns. In this case, John's actions are column oriented, so we have to go row by row and see which column makes sense for both rows. Before moving on to Nash equilibrium and prisoner's dilemma, if you need me to explain to you your entire microeconomics class in 2 hours, go on my site and unlock all 95 of my concept breakdowns. Essentially, they're like TikTok clips that just step-by-step walk you through what you need to know. And yes, it's completely free to unlock with your email. Okay, Nash equilibrium is about which cell both parties are comfortable resting at. So I've highlighted in yellow here this Nash equilibrium in this game. How you can test if a cell is Nash equilibrium is to assess the other option. Let's zone in on John here. Right now, John's getting 5 years, but if John changes from confessing to staying quiet, he gets 10 years, which makes no sense. He's not gonna do that, so he's gonna be comfortable sticking with confessing. Similar to Sarah. Sarah right now is getting 5 years by confessing, but if she were to switch her action and stay quiet, she'd get 10 years, which once again makes no sense. She has no incentive to do that, so she's gonna stick with confessing. Thus, since no parties have any incentive to switch off of confessing, that's gonna be the Nash equilibrium. The game will rest in that cell. There can be 2 Nash equilibriums, and if you wanna see an example, go on my site. Now, the whole prisoner's dilemma element of this, typically professors start with this, but low-key it kind of makes more sense when you end with it, is that the Nash equilibrium was right here, right? Both parties are going to rest at confessing, when in reality, if they were to collude, this would actually be the better option for both parties. Prisoner's dilemma focuses on how when we act independently, we might miss out on the actual best option for both of us. Because acting independently here, let's assume that Sarah and John met before they got interrogated and were like, let's both stay quiet, it'll be better for us. And then Sarah goes, hey, wait, hold up, I'm right now staying quiet here, but if I were to confess, I'd go free. I'm gonna confess. And John have the same exact thought. He'd say, all right now I'm staying quiet, but hey, hold up, if I confess, I'm gonna go free. I might confess here. See how both parties acting in their best self-interest actually moves them away from the cell that's better for both of them? That is the prisoner's dilemma.